Hello. We are in Unit 4, Module 2, Session 3. The name of this home connection is Number Cards. Please place your name and number at the top of the page. This whole page is going to deal with Haley and this activity she's doing with number cards. She pulls 6 cards from a deck and she arranged them into 2 numbers. They each have 3 digits, 348 and 956. Question number 1 says, what is the sum of Haley's 2 numbers? You can use whatever strategy you want. They just want to see your work. I think you could stack and add and use the standard algorithm for addition, but it is your choice. However, if you are going to stack and add, let's try it. 8 plus 6 is 14. Carry the 1. Okay. 5 plus 1 plus 4 is 10. Carry the 1. 9 plus 1 plus 3 is 13. So my answer is 1,304. Regardless of what strategy you use, you want to end up with this number. You can break the numbers apart. You can use a number line, expanded form. You choose. Okay. Question 2 says, what is the difference between the 2 numbers? If you are going to use the standard algorithm for subtraction, please remember to place the larger number on top, or else you will get a negative number that we have not worked with yet. 6 minus 8, oh no, there is more on the floor, so we need to go next door. So I'm going to borrow 1 from this 5, which turns that 5 into a 4. Now I can take 16 minus 8 and get 8. I can take 4 minus 4 and get 0. And I can take 9 minus 3 and get 608. If you wanted to use some give or take, if you wanted to break the numbers apart to do subtraction, you can use whatever strategy you want, but you do want to get this answer. Okay? According to the rules that we learned about, if you have any 6 numbers, like she had 9, 5, 6, 3, 4, 8, if you took her 6 numbers that she drew from the deck and you wanted to make the biggest number you possibly could, the rule is that you would want to start with the biggest number and end with the smallest number. So it's reverse numerical order. So I would go 9, that's the largest number, and then 8, there's no 7, then I do a 6, a 5, a 4, and then a 3. If I were to have any doubled numbers, let's say I had 6 and a 6, well, you would have those in the same spot, 6, 6, and then the remaining numbers. So just put the dual numbers right next to each other. Keep it in number order, reverse number order. So I'm getting smaller as I go down. Okay? If you take those same numbers and you want to do number 4, what is the smallest number she could make? Well, if reverse number order is the largest, then number order is going to be the smallest. And I'm going to let you do that one on your own. Pause this video if you need to. Haley chose 6 more cards. This time she made these 2 numbers, 278 and 421. Haley says she can add these 2 and get the same answer as adding the numbers that she made. Do we agree or disagree? According to our rules, or that we've been practicing in class, we need to set up a balanced equation. So we said 278 plus 421. She thinks that you could get the same answer by adding 299 and 400. Okay. We know that you have to do give and take in order for this problem to be correct. Is that true? Let's find out. Let's say I did 2 plus 3 is the same as something plus 5. Okay, what does this blank need to be? Well, 2 plus 3 is 5. What plus 5 is 5? 0. So what happened to this 3? It looks like they added 2. What did they do to this 2 to make it a 0? Subtracted 2. So in order for an addition problem to be balanced on the other side, whatever you give to one number, you have to take from the other. So using that information, how did they turn 421 into 400? Well, they had to subtract 21. And according to our rule, give and take, if you take away from one number, you have to add it to the other number. So they take 21 away here, add 21 here. 278 plus 21 is 299. So we agree. Why do we agree? Because they used give and take. And they did it accurately, right? So if you have an addition problem, and you're going to make the numbers more friendly, it's a lot easier to add when you have a 400, right, than these two numbers here. They don't look so nice. So they got rid of 21. They took it away to get an even 400. But in order for this problem to work out, you have to use give and take. So if take away 21, add 21, and you still get the same answer. Okay? Haley says she's going to find the difference between 421 and 278. Notice that I put the larger number first. She said she can get the same answer by taking 443 and subtracting 300. So it looks like she tried to make this 278 a lot more friendly by turning it into 300. When you use difference, you can no longer use give and take. You either have to use give or take. Why does that work? Well, let's say I took 3 minus 2 is the same as 5 minus blank. Okay? 3 minus 2 is 1. 5 minus what is also 1? Well, it has to be 4. Okay? What did they do to this 3 to turn it into 5? Well, they had to add 2. What did they do to this 2 to turn it into 4? Well, they also had to add 2. So if you're working with subtraction, if you add to one, you add to the other. Likewise, if you were to take away from one, you'd have to take away from the other. So addition problems use give and take, where you have to give and take, add and subtract to both numbers. But if you're subtracting, you have to use give or take. Okay? So what happened in the problem that she did? Well, it looks like she gave 22. 278 plus 22 is 300. And the rule is give. So did she add 22 to this number? 421 plus 22? She did. So we do agree because she used the give strategy. Looking at my pairs of fractions here, we are going to be using only hundredths. And notice these don't match. What is our rule for tenths? We can turn it into hundredths if we add a 0 to both numbers. When we're working with fractions and we're adding and subtracting, the denominator never changes. So once I have hundredths, I'm good to go. You can't add those to get 200 because the 100th, a hundredth, refers to how big the pieces are. The numerator refers to how many of those pieces we have. So I have 50 pieces that are this big and 37 pieces that are this big. How many pieces do I have that are this big? 87 of them, because I add 50 plus 37. You're going to use this strategy for all of them, trying to make sure that you have hundredths as the denominator. So make sure you're using our strategy of converting tenths into hundredths by adding a 0 to the numerator and the denominator. Okay? Pause this video and work on those, please. Working with this number line, we're going to place all of these decimals in order. If you look at only the tenths, which is the digit right after the decimal, you can look at all of those numbers, and if you put those in number order, you should be perfectly fine. going to put 6 marks on here since there's 6 numbers, and I'm going to find the smallest number, which is a 1. So I'm going to put 0.1 on the number line, and then I find a 2, a 0.25. What's the next largest number? A 4, 0.4. Then the next largest number, oh, there's a 5, 0.55. Then I have 2 more numbers, a 0.8 and a 0.95. 0.8 would be smaller, and then 0.95 would be the largest. So just by looking at tenths, I can put these in the correct order. However, another handy strategy might be to convert all of the numbers so that they match. These last 3 numbers, that says 95 hundredths, 55 hundredths, 25 hundredths. But these are all tenths. 8 tenths, 1 tenth, 4 tenths. If I add a 0 to those 3 numbers, now I have 40 hundredths, 10 hundredths, 80 hundredths. Now I can look at all of these numbers and compare them really well. 10 is the smallest, followed by 25, and then 40, 55, 80, 95, and it works out in the exact same order here. So that's just another option. Keep that in your mind, okay? In this problem, we have a lot of students in the school. 137 third graders, 139 fourth graders, 153 fifth graders. We want to know how many students in all. So I would consider doing a stack and add. Just use your standard algorithm for multi-digit numbers. Make sure you stack them beautifully. If you do use this strategy, just make sure you carry the appropriate number. You are going to have to carry twice. So you're going to need a number here and a number here. Make sure you carry the correct one. I am going to let you do that on your own. In our last question, Sarah, Rex, and Peter are all friends. Okay, they all live in different colored houses. Looks like there's a red house, a blue house, and a green house. Okay, red, blue, green. Now here's the riddle. And I'm going to write their names down to help us out. Rex, Peter, Sarah. It says, the person who lives in a greenhouse has more than 3 letters in his name. The person who lives in a red house is not Rex. Which person lives in each house? The first clue says the person who lives in a greenhouse has more than 3 letters in his name. Well, Rex is 3 letters, so he's out. Both of these names have more than 3 letters. The person who lives in a greenhouse has more than 3 letters in his name. Has to be Peter. The person who lives in a red house is not Rex. So if Rex doesn't live in the red house, Sarah has to. Which means Rex lives in the blue house. Sorry that my handwriting was off. If you have any questions about these problems on this home connection, please make sure you contact a math wizard that you trust. Friend, family member, teacher, we love to answer questions. Okay? Good luck finishing.